Hey, welcome back to Mr. P Helps with Algebra. This is Unit 4, Topic 3, Lesson number 2. We're going to be doing, last lesson we did zero product property. This time we're going to do square root method. So we're still solving quadratic equations. First warm up, we've got multiplying, FOIL method, first, outer, inner, last. That gives us x squared minus, no, outers would be plus 3x. Minus 6x would be the inners, and then negative 18 would be the last. So that gives us an answer of x squared. Combine those two like terms in the middle, makes negative 3x minus 18. Question number 2, FOIL again. We have a binomial times another binomial. In other words, you have to multiply everything in the first factor times everything in the second factor. So that gives us x squared minus 4x minus 9x on the inside, and plus 36 for the last. Combine the two like terms in the middle and you get negative 13x, and then you can bring down your constant and bring down your x squared. And that's it. Another FOIL question. So x squared plus x plus 12x plus 12. So that's going to leave us with the answer. Combine the two like terms of x squared plus 13x plus 12. And then this question. So it looks like we have something that resembles vertex form. We're going to change it to standard form. First thing I'm going to do is multiply what's inside the parentheses times itself. It's a perfect square, so I can use a little bit of a shortcut method. I know x minus 5 is going to become x squared, because that's going to be the first, and the last is going to be positive 25, but the outers and inners are going to be the exact same thing. So we can just basically multiply the two terms by each other, and that would give us negative 5x, and double it makes it negative 10x. Plus 25. Okay, so times itself, multiply and double it. Now that shortcut only works if it's a perfect square. That's a perfect square of x minus 5. X minus 5 this way, x minus 5 this way with an area model, and you got yourself a perfect square. Now we need to multiply everything by 3, so we get 3x squared minus 30x plus 75. All right, so let's go on to the lesson. So as I mentioned before, we done in the last lesson zero product property to solve. This time we're going to do the square root method. Because what you may or may not already know is the square root of 25 isn't just 5. The square root of 25 is actually both positive and negative 5. So 5 and negative 5. Because anytime you're taking the square root of a positive number, it actually has two answers. It's got a positive answer and it's always going to have a negative answer, because a negative times a negative is also a positive. So how would I solve that algebraically? I would do the square root. Well, you just saw me do it on the up here. I would do the square root of both sides, because whatever I do to both sides, that's going to stay equal. The square root of x squared, what times itself as x squared, would be x. And the square root of 25 would be both positive and negative 5. And I missed an equal sign in there, but I think you get the right answer. Equals positive and negative 5, like that. All right, how can you solve this equation? Well, I'm going to do the exact same thing. I'm going to do the square root method. I'm going to take the square root of both sides, because both sides are perfect squares. Now, think about this for a second before I do this problem, that the square root of 3 squared is 3. The square root of 9 squared is 9, because the square root of something squared, those are basically just canceling each other out. Those are the opposites of each other. The square root means what times itself equals it, and if it's already squared, that means it's already times itself. So anything squared, the square root of anything squared is literally itself. Now, it doesn't have to be just a number as the base. It could also be an expression. X minus 2 squared, the square root of x minus 2 squared would be x minus 2. And then the square root of 16 has two different answers, as we had talked about before, both positive and negative 4. So then what I could do then is then solve it twice. Do x minus 2 equals positive 4, and x minus 2 equals negative 4, and I'll find my two answers, which happen to be 6 and negative 2. 6 and negative 2 are the two answers you could put in for x, and it would be equal on both sides of the equation. Now, in this lesson, they have 3 characters, Tia, Tahani, and Zach. And each person likes to do it a different method. Tia likes to do the square root method, which is what I just showed you a second ago. Tahani likes to do the zero product property, as you can see down here. He likes to turn it into factored form and then set each factor equal to 0. And then Zach likes to graph it and look at to find what are the x-intercepts. Or, in this case, if it's not set equal to 9, we'll find out when does it have a height of 9. So that would be the graphing method. Tia's method. Now, Tia did it incorrectly. Tia found one solution. Tahani found two solutions. Who's correct? Well, Tahani's correct, because Tia forgot that she needs to solve it a second time. The square root, if she's going to do the square root of both sides, the square root of 9 is both positive 3 and negative 3. So she had to solve it twice. So x equals minus 1 from both sides makes negative 4. So there's actually two different answers, as you can see clearly down here. Tahani took this, and yes, it looks like a lot of work. It is a lot more work in this case because not one strategy is always going to be the best strategy. And you'll find it later in the future lessons how to figure out which method is going to be the best. Sometimes zero product property would be the best if it's in factored form. Well, I guess I'm giving answers away here. Oh, it even says it right here. TIAS is always the best when it's, TIAS is the square root method. It's the best when it's already a perfect square on the left. Or if it's not, then you can actually complete the square to make it a perfect square, but we'll talk about that later. And then Zach's is the best if the answers are integers. Usually, if it's a decimal, Zach's method's not very good. You can use a graphing calculator to find non-integral answers, but you want the answer to be integers in order to be easy to graph. Otherwise, if the answer is between 1 and 2, well, how do you know what it is? It's between 1 and 2. It's not really very good for that. Well, Tahani had the first change vertex form into factored form, and then he can set each factor equal to 0 and get the answers. Whereas Zach's method, what he's going to do is he's going to simply graph it. So you put x plus 1 squared into your calculator, and then you graph it. So x plus 1 means it's going 1 to the left. Sorry, it's vertex form. So x plus 1 squared is 1 to the left. And then it looks like the next one's going to be 1 up. And then the next one's going to be 4 up. So it's going to look something like this. And then the 2 points when it has a height of 9, those are the two answers, which should have been at both positive 2 and negative 4. Now, I think I drew this a little bit wrong. It should have been actually like right there. It should have been the answer. But I think you get the right idea. Those are the 2 points when this function, or that equation, I shouldn't say equation, that function had a height of 9, because it is an equation in the end. All right, so let's get back to this. We want to talk about zero product property. I'm sorry, not zero product property, square root method. So modify TIAS, well, I already did that on the last page. TIAS method, so if I have x minus 3 squared equals 4, this is a perfect question for TIAS method. This is a perfect, I want to say square root method, because it's not really TIAS method. Perfect square on both sides. Notice that this is a perfect square, and 4 is really a perfect square because it's really just 2 squared. It's a 2 by 2 square. So this is going to leave you with x minus 3 equals both positive and negative 2. Square root of 4 is both positive and negative 2. Now you're wondering, why isn't this side positive or negative? Because remember, the square root and the squared canceled each other out. So the answer is just literally itself. There is no other answer to this side. So we get x minus 3 equals 2. And x minus 3 equals negative 2. Solve it twice, and we get x equals 5 on this side, and x equals 1 on this side. Now, I can do Tahani's method. I can change this into factored form. So I'm going to change this into standard form first. I'm going to use my shortcut method here. So x minus 3 squared is really an x squared minus 6x plus 9 equals 4. Set it equal to 0. Subtract 4 from both sides. Gives me x squared minus 6x plus 5 equals 0. What two numbers give you 5 but also add up to 6? And that would be x plus 5 times x plus 1. Okay, it's got to be negative. Sorry, it's negative 6x. I did not read my handwriting. So it's going to be x minus 5. So negative 5 times negative 1 is 5, and negative 5 plus negative 1 is negative 6. Set each factor to 0, and x minus 5 equals 0, and you're going to notice that you're going to get 5 is the answer, and x minus 1 equals 0 gives you x equals 1 is the answer. Now, you should not be shocked that these two strategies got the exact same answer. Now, when I graph this equation, it looks like it's going to go 3 to the right, 1, 2, 3. It's a transformation of vertex form. And it's going to be up 1 from there, then up 4 from there, then up 9 from there. So something like that. Now, when did this function have a height of 4? It looks like at 1 and 5. Once again, should not be shocked that you're getting the exact same answer for all three strategies. Now, I'm not going to do all three strategies again down here, but I am going to do TIAS method because that's what today's lesson is all about. Square root method. So square root of x plus 2 squared That's already a perfect square, so that's perfect. Oh, -1. Okay, so I got to get rid of that -1. So I'm going to add 1 to both sides. So I'm going to get the 1 over here on the other side, and that's also a perfect square. All I did was add 1 here and add 1 here. 0 plus 1 is 1, and then that eliminates itself from the left. So that leaves me with x plus 2 equals both positive and negative 1. Solve it twice. X plus 2 equals 1, and x plus 2 equals negative 1. Subtract 2 from both sides gives you negative 1 here. And subtract 2 from here, it gives you negative 3. So the answers are negative 1 and negative 3. All right, down here, look at each equation below and determine which method you think will be the easiest. Now, this one's in standard form. Personally, I would use quadratic formula, but that's not one of the choices yet because that's in the next video. But if I was given this, I notice that this is factorable. 9 times negative 2, so I could easily change this to factored form. So I'm thinking Tahani's method would be the best for this. This is a perfect square here, and if I move this over here, it would be a perfect square over here. So that's Tia's method. Or you could use Zach's method. It'd be just as easy. And this is also a perfect square on both sides, so I would say Tia's method would be better. The square root method, because both sides are a perfect square. All right, let's get to that homework. Looks like here we're using square root method again to take the square root of both sides. So x is both positive and negative 7. Done. That's the answers. Positive 7 and negative 7. Take the square root of method on both of these. We get x minus 8 equals both positive and negative 3. I'm going to set each equal to x minus 8 equals negative 3. I'm going to set it equal to both answers. Add 8 to both sides makes the answer here 11. Add 8 to both sides makes the answer here 5. Question number 7. First thing I want to do is I want to make both sides a perfect square. In order to make the left-hand side a perfect square, I got to get rid of that minus 25 by adding 25 to both sides. So that's going to give me x plus 6 squared equals 25. Do the square root of both sides. X plus 6 equals both positive and negative 5. Now I'm ready to solve. X plus 6 equals 5, and x plus 6 equals negative 5. Subtract 6 from both sides means x is negative 1. There's one answer. Subtract 6 here, and you get an answer of negative 11. So there's your two answers. Boom and boom. All right, I'm going to erase that. Let's go down to question number 8. I want to get rid of the 36. I want the left-hand side to be a perfect square, and it'd be a perfect square if x squared was by itself. So once I add 36 to both sides, this is what I got. So it looks like this is going to be an easy problem. X is both positive and negative 6. This one, okay, a little bit more tricky. I want to make the left-hand side a perfect square. I want to get rid of this 48, and I want to get rid of this 3 so that all I have left is this x plus 1 square. Yes, I said it like that on purpose. So first thing I'm going to do is add 48 to both sides. So that gives me 3 times that x plus 1 squared equals 48. But then I want to get rid of that 3. Right now it's being multiplied by 3, so I'll do the opposite, which is divide by 3. So I've got my x plus 1 square, which is what I want. I want that perfect square on the left. And 48 divided by 3 happens to be 16, which is also a perfect square. So that's perfect. Yeah, perfect. So that's x plus 1. I've run out of room here, so I have to write over here. So x plus 1 equals 4, and x plus 1 equals negative 4. Subtract 1 from both sides means one answer is going to be 3, and then the other answer looks like to be negative 5. I'm going to have to erase that because I took too much room there. And question number 10. It looks like we're given standard form, so the first thing I want to do is... wait, do I have to use... Oh, okay. I don't think I have to use Tia's method. I'm going to use Tahani's method, which is I'm going to factor this. I'm going to put it in factored form first and then use zero product property. Ask myself, what two numbers give me negative 24 but also add up to negative 2? Well, that would be negative 6 and positive 4. I'll check that just in a moment to make sure before I go any further. Negative 6 times 4 is negative 24, check. And negative 6 plus 4 is negative 2, check. Set each factor equal to 0. And then I can solve. And I see I'm getting low on time here. So x does equal 6 and x equals negative 4. All right, thanks again for watching. Please give it a like if it helped you learn how to use the square root method in order to solve quadratic equations. And definitely keep following me. Thanks again for watching. Have a great day.